All right, today is November 1st. Everyone's coming down from their candy high from last night. Uh, Lovely students brought me in copious amounts of my favorite Halloween treat, which are cheesies, which is great because I didn't even have to promise them anything. I just said, I love cheesies, and they brought me in stuff. So I'll just make sure I reward those who were very thoughtful with being thoughtful and kind. So we have 4 questions here this morning, each one from section 3.1 of our Math Power 9 textbook, all doing with exponents. So the first question says, in words, describe negative 2 squared versus the opposite of 2 squared. So I'm going to write it down for you. The first one says negative 2 squared, so negative 2 squared. And I can confidently say that's negative 2 squared because the brackets are around what we're going to call the base. So negative 2 has brackets around it, which means that is your base, which means we're going to square negative 2. Is not equal to, or is not the same as, actually is not equal to, I guess is better. Now when I look at this, there are no brackets around there, are there? So because there are no brackets around it, I am not going to say negative 2 squared. What I'm actually going to say is the opposite of 2 squared. So this idea of the opposite of 2 squared, the opposite of, it's really how we interpret an unbracketed negative sign. It is not negative 2 squared. It is the opposite of 2 squared. So when we think about that, and I'll use another highlighter here. Let's go with green, I suppose. Negative 2 squared. What does that look like? Negative 2 multiplied by negative 2. That's what negative 2 squared means. Does not equal the opposite of 2 squared. So negative 2 squared is going to be a positive 4 because of our sign rules. Does not equal, excuse me, the opposite of 2 squared. Since 2 squared is 4, the opposite of that, you can also think of the opposite as being a negative 1 multiplier, because when you multiply numbers by negative 1, you will always create their opposite. So if I take 4 and multiply it by a negative 1, I actually get its opposite of negative 4. Okay? So basically, to recap, negative 2 squared is not the same as the opposite of 2 squared. Why? Because this is what negative 2 squared looks like, and this is what the opposite of 2 squared looks like. Okay? Any questions on that? Does it make sense? Okay. Our second question gives us just a subtraction question. Now, if I read this properly, is negative 4 in brackets here? Yes. So how do I read that? Because the negative 4 is around the base, or the brackets are around negative 4. I read that as negative 4 squared, which in repeated multiplication will be negative 4 times negative 4, which is a positive 16. Now this is a subtraction sign, so I'm going to write a subtraction sign. Now the question is, do I read this as negative 3 squared or the opposite of 3 squared? Now, a lot of people are going to say I'm supposed to read it as negative 3 squared because there's brackets around negative 3, but they'd be wrong because the brackets are not around the base, are they? The brackets are around the entire power. And we have to ask ourselves, why would I have put, Mr. Jelly, why would I have put brackets around the entire power? And the answer for that is because I want to separate it from this. If I did not have brackets around the negative 3 squared, it would look like this, right? So the only reason I have brackets around it is because I want to make sure I separate the power, the negative sign, from this. So that really says the opposite of 3 squared. The opposite of 3 squared. What is 3 squared? 9. What's the opposite of that? So because this answer here is negative 9, I have to use brackets here, don't I? Because I need to separate it from my subtraction sign. Then I'm going to keep flip change. And my final answer will be 25. Okay. It's a good differentiation between, is my base negative or is my power negative? Does that make sense? The difference between it is, yeah, you were wrong. Because you kept it as take away 9 probably. You probably keep change. Or keep flip. Either or, it doesn't matter. Okay, second question gives us a standard table. It gives us a power, repeated multiplication in standard form. So 3 to the exponent of 4. Remember, exponents of 4 I mean, how many times do I multiply the base by itself? There's 1 time, 2 times, 3 times. Exponent of 4 means you multiply the base of 3 by itself 4 times. 3 times 3 is 9, times 3 is 27, times 3 is 81. Standard form. The next one, there are brackets around the -1, which means -1 is my base. It's being multiplied by itself 3 times. So we have a 3 exponent. An easy way to remember this, Grace, is if you have a negative base, which we do. If it's an even exponent, our answer will always be positive. If it's an odd exponent, we'll always have a negative standard form. So -1 times -1 times -1 is always going to be a -1. And finally, the last one, 1,000 in standard form. Does anyone know what exponential form we could use for this? 10 cubed, correct? Or 10 times 10 times 10. Now, there are smart people that say, what would this be? That'd be -1,000, right? But what if I did this? That says the opposite of -10 cubed. So -10 cubed is -1,000. So what would this be in standard form? It would still be 1,000, wouldn't it? And this would be a -10 times -10 times -10. So a standard answer will be this. A real smart person attacking this question may choose to write it this way, right? Both are correct. If you can understand the yellow one, you're way ahead of the game. You're way ahead of the game. And that was the last one, right? Well, no, this one here. So our last question is a story problem. It says using this formula right here, SRT. So S represents the starting number, R represents the rate of change, and T represents the number of time intervals. So 5 bacteria are in a dish. They triple every 15 minutes. How many after 2 hours? Question mark. Question mark. So our starting number is 5 bacteria multiplied by the rate of change. It triples every 15 minutes. So the rate of change is going to be tripling, which we represent with the number 3. And how many 15-minute intervals are there in 2 hours? There are 8. So our T, or our number of time intervals, will be 8. And now we have 5 times 3 to the exponent of 8. In the past, we've never really used our E, but our E is exponents. Our B is brackets. Is there anything inside those brackets to solve? No, it's just the number 3, so it's not really a brackets thing. But there is an exponent. And 3 to the exponent of 8 is going to be a big number that I can't comprehend without a calculator. So I'm going to put 3, and I'm going to use this XY button. I'm going to put 8, I'm going to press equals. That says 6,561. If you didn't know have that XY button, you could just do this. 3, 2, 3, 4, 5, 6, 7, 8 equals. And you get the same answer, right? If you have an XY button, you can use it. Otherwise, just multiply 3 by itself that many times. So when my answer gets 6, oh, oopsie daisy. I get 6,561, which is what 3 to the exponent of 8, multiplied by 5. Take that same number. I'm not going to press clear. I'm just going to hit multiplied by 5. And the answer is 32,805 bacterium after 2 hours.